Welcome everyone, this is the third episode of the Rust tutorial series, and today we'll cover a super important topic, which is data types. In the previous episodes we saw hello world and variables, we saw some interesting concepts in Rust, but today we'll talk about really the basics. So what are data types, what kind of data types we have, just a couple of examples and we'll be done. This is a first episode about data types. We'll have more advanced data types lessons in the future, but I think we can start. So just a kind of reminder that Rust is a statically typed language and compiled one, of course, and it means that it needs to know all the types of all the variables at compile time, otherwise it will throw an error. The compiler can usually infer the type, can imagine the type and adding this for you. For example, if you initialize a variable like let x equal 10, it will understand that it's an integer. We'll see this today, but sometimes we need to add this type by ourselves. We saw in a previous example, for example, if we declare a constant in Rust, we need to specify the type. Okay? Nice, so let's see what kind of types are we talking about today. I'm typing this on the screen so it will be easier for you and even for me to remember. So, data types in Rust. What kind of data types we have? GitHub Copilot is helping me here. We have scalar types, and we'll see here 4 types. One is integers, one is floating point numbers, one is Booleans, and one is characters. Those are the 4 basic scalar types in Rust. Then we have compound types, and compound types they have multiple variables in the same type, I will say. And as a compound types we have tuples and arrays. This is what we have. And we also have custom types. This is what we will see today. Custom types, we'll see 2 types of custom types, the most important ones, structs and anams. So this is all we will see today. Yes, okay? Can we add multiple types or change? So to see if you can change the type, you can see the previous video, which is more about variables. So here we're just talking about the types, what they are and what they can do. Short answer, you can't change the type unless you use shadowing, check the previous video, or you can change the value of a type if you have a variable declared as mutable. So this is a concept about mutability. It has been said in the previous lesson, the one shoe. Okay, so you can check it out. It's 8 minutes video, absolutely recommended. This is now I need to focus here on the data types. Okay. Nice, so let's start with the scalar types. So let's remove this one. Oh my god. Okay, so let's talk about the integers. So very simple, but we need to understand what kind of integers we have, how they are defined, and so on. So we have many different types of integers in Rust. We have signed and unsigned, of course, with a sign, and if we want them to be just positive, I want to copy paste here a table so we have an idea. Let me do like this. So we have, you can see here, in length 8-bit, 16, 32, 64, and 128 bits. We have signed and unsigned. Let me do like here, 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 here. We have also this one we will not see in this video, but it's interesting, which is dependent on the architecture here, arch. Okay, so these are the basic integer types in Rust. I want to show you some basic examples here. For example, we can define one as a small number. It's okay. Then we can have a big number. I think this is a bit too big. Let's make it a bit shorter, like this. Okay. And now we can have also, so big number unsigned. We can have a small number as an integer. It can also be negative, and a bigger one also negative, I would say. Now here you see on the right we want to, I don't know, let's print these values. So for example we can have print here, println, small number, big number. We are using string interpolation here. Let's see here, print small number. Okay, I want to name this in a different way, otherwise can be confusing. So small number 2 and big number 2. I don't want, could be actually possible, but I don't want this to be confusing. So small number 2, big number 2. Now here on the right, let's just type, if we type here, let's see, cargo run, okay, we see that we have some warning here, but because we need to add this here. Let me do this. So, okay. So if we wanted to print this on the screen, we can type cargo run and we can see this. To be honest, I'm a bit annoyed by this compiled, finished, and running every single time. So what we can do in this case, we can do cargo run with the option -q, which stands for quiet. A moment. Let me put this here. It's a bit confusing. Okay, so if we use the option cargo run -q, we just have the output here. Okay, nice. Yes, for the println with exclamation mark, I say this in the first lesson. The short, it's a macro and not a function. You can try without the exclamation mark, it will work anyway. Nice. What else? About decimal, about integer literals. So if we usually use the decimal types when we want to define a number, but let's say that we want to use a different numeral system. So let me copy paste this. So we have an idea here, like this. Okay, like this. Okay, so we can have decimal, hexadecimal, octal, binary, and byte. Let me see this also like this, so it's easier to understand. So we can have let decimal, which is the default one, decimal. We can have a number like this. We can have an hexadecimal one here, octal one, binary, and byte. Okay, and let's print them all here with hexadecimal, hex, octal, binary, and byte. Okay, so again here let's do cargo run -q, and we can see here we have the representation in decimal of the relative integer literal. For example, the hexadecimal one, which is 0xFF, becomes 255, of course in decimal, when we will print out. Okay, nice. Now another type, let's remove this. Okay, so this was the first type. Now I want to show you, very simple, the floats or floating point, I would say. The floating points, very simple, we have two ones. We have F64 and F32. F64 is the default one and it's a double precision float. The 32 is a single precision float. So in Rust, the default one is the F64. This is, you see here, this is the default. Or we can have also this. We can declare the type, of course, if we don't want the default one. So this will be an F64 because that's the default one. Otherwise, this can be inferred as a type. In this case, we'll have F32. Okay, so very simple. We can print them out. Println. I also want to show you some basic operations here. Numeric operation. We can have as a sum x plus y. I want to give an answer here. Decimal contain dot. The underscore is just when you define them. It's a convenient way to define it. Even if you don't use the underscore, it will work. It's just a way so humans can actually define them in a proper way, so I don't know, they don't miss a 0 or a number. But if you type just 5 numbers, it will also work. I just auto-completed, it was just something to show, okay? I hope it's okay, Saurabh. Nice, okay. Basic operations, nothing much to say here. Sum, difference, product, and quotient. As I said, this is not, Rust is not the first programming language you should know, so probably you already know these basic operations. I want to print them all. Also reminder. Cool. Let's print them all. We can print the sum, difference, product, quotient, and reminder. Let's see. Control L. Cargo run. We have 2 and 3, and this is printed without the command here. Sum, difference, product, quotient, and reminder. Probably we'll make a lesson when we will go more deep in details for operations, but I just want to show that you can do basic operations in Rust. As far as I know, there is not F16 and F128. It might also be the case. I will check it out. You can check the documentation. This is the basic video, but I will check it out. Okay. You can check it AD and let us know in the chat. Okay. Nice. Okay. Here. Nice. Now the Boolean type. This is a very simple type, Boolean type. The Boolean type is represented as a false or true. It's a 1 byte inside, and as I said, I can only take 2 values, true and false. We'll also see something interesting here that is not common to all the programming languages. Of course, Booleans are used usually in conditional statement. We'll have a dedicated lesson, I think it's the next one, about control flow, so if and all the other constructs. But of course, I think that most of you already know what an if statement is. So we will see an example now. So we can have this: let t equal to true, and this is an implicit definition, declaration. This is an implicit declaration. You can see I didn't say that this was a bool, but since I assigned a value as true, the compilers understands that this is a boolean. Otherwise, so I can do an explicit declaration here. Let f bool equal to false, and this is an explicit declaration. I can print them like this. And then I can try to use them, this is a spoiler, and then I can try here to use it in an if statement. So for example, we can say if statement, we can say if t print t is true, else print t is false. It's very basic, okay? And then I want to try to run this piece of code. Let's see how this will go. Okay, here. I want to clear. Okay, now let's try cargo run -q, and we have t true, f false, t is true, perfect. Okay, and what else? Here we can also do something. We can use an exclamation mark before the boolean to basically change the type. So we can have let not t, which is t with an exclamation mark, and if we print it here, we see that here not t is false because t was true. Of course, if I change here to false, if I can spell it, if we change here to false and we run this again, we see this not true equal true. It doesn't make sense, but it's okay, and t equal false. I want to show you something about booleans. Can the value assigned to the boolean, is there a default value assigned to a boolean? So if I say let b bool, will Rust like this or not? Like, I don't know, maybe there is a default true or false value assigned to a boolean, like there is in some other languages. What do you think that will be the output here if I print this statement? Do you think this will return true, false, or error? Let's see. Subscribed, thank you so much, Lightning Bolt. Love the... Is that a World of Warcraft reference? The provider case. Yes. Ciao. False. Tebbo says false. False. Undefined. I don't think we have undefined in Rust. Let's see. I mean, if you're coding along, you already know the answer. So you have two choices here. You either cheat, it's not cheating, or you can try to guess, I would say. You see the default value is false in Rust. So you think that it's guessing, it's assigning the default value of false. I want to leave 1 more minute here. Let's see. False. Okay, let's see. Let's see. Interesting. Let's see. I want to see. So I see false, false, undefined. Nobody say true. I'm JavaScript background, undefined. So yes, we don't have undefined in Rust. Undefined is, I think, specific to JavaScript. Because JavaScript assigns a value. In this case, we'll have something, or at least it assigns undefined. What about error? It might also throw an error. I say, what's the output of this piece of code? Like, it's just 2 lines, but like, what's the type? What's the output here? Should I run this on my system? I'm gonna do this in 1 minute. So, I mean, you can. It's that will be the best solution to understand. But you can also just keep watching, and you will have the answer soon. Nice. I hope you like this type of. Because this was the best type also for me to understand things. Nice. Are we done? So we have 0 true. Most of us are saying false. It can also give false with warning. Interesting. We have false with warning, error. B is not initialized, so I think it will throw an error. Might be. We'll see. Okay, let's just run it. Can't wait. Let's go. Let's try. Okay, so again, cargo run -q, so we don't have compile, run, and finished. We just have the output. Are you ready? Francesco, could you make live on how to integrate GitHub Action with Docker Compose? It's Docker Composer is something PHP, but let's focus on Rust now. But I can do it. Just keep focused on the channel. Cargo run -q. Bam, error. Again, error. So whoever said false was a mistake. Let's read the compiler. So who said AD was right, was correct. B is not initialized, so I think it will throw an error. Let's read. Binding declared here, but left uninitialized. You see here there is a red arrow here. Actually, used here, but it isn't initialized. No, there is error regionized in the macro, okay? And I love, see, the cargo compiler is literally trying to suggest us what to do. You see, equal, false, all green with all these pluses. I love it. So it's like explaining these things to a child, like you have just to put this like this. You see, we have exactly how this should look like. Let's see the chat. Why we got the error? We got the error because the compiler wants this to be initialized. We need to initialize this. That's the thing. Let's try like this. So let's try to initialize as a false. And now it's working. Okay, so Booleans they have to be initialized, otherwise we'll have an error, and similar to other types, of course. Okay, nice. I want to do this. I want to remove this. Okay. Okay, and now characters. Okay, so a char type is a 4 bytes in size and is used to represent a single Unicode scalar value. This means that you can encode a lot of things. We have 4 bytes. We have no idea how many types. I think millions. We can put it here. So it can represent many different characters. For example, let's see equal z, the single one. We can also put this. I want to change this example to let x equal the big X, the Twitter X, 1, or we can even put emojis as a single character. For example, this hide card. For example, this heart hide cat. We can print all of them, cargo run. We can see Z, the X of Twitter, and also this heart hide cat. We can also iterate characters. We can also iterate over characters in a string. For example, iterating over characters in a string. For example, for char, there are 2 types, but let's use this one. I want to put this one. Hello. Oh, no. We can put ciao, namaste, if I'm not wrong, pray. Let's see if this does work. Okay, nice. So now I know how to. I don't know if it was namaste. Was it namaste or not? It's hard. It's very hard to write Hindi, but I tried my best. Okay. You can't declare a variable. You can initialize a variable even later, but it has to be initialized. Okay, nice. I made it. I want to take a screenshot. Nice. Let's go. Namaste, Rust. Love it. Let's go here. I want to put this letter. It's written correct. I don't know what's going on here. I see some strange characters. Maybe they are the accent. I don't know. Oh, okay. I need a bonus for this, okay? I went the extra mile. Nice. Okay, perfect. Okay. So in this example, basically we can see these 3 types of characters. There are many more, and then we saw how to iterate over characters in a string with these 4 char in this string. And here we have a mix of different characters, also an emoji, and as you can see here, we can iterate and print them all every time on a new line, because we used the print ln exclamation mark macro. There are also char like vocals. Interesting. Put this here. I think this is better. Nice. Okay. Nice. Let's go here. We are almost done, but I wanted to also show. Okay, so these were the default scalar types. Now we need compound types and custom types. So we're almost done for today, and we need. So let's see tuples. Now let's see tuples. Okay, so in Rust, a tuple is a versatile way to group together a different number of values. We'll see this soon, in a matter of seconds, of different types. It's very useful when you need, for example, to return multiple values from a function. Especially, this is a great use case. We didn't see the functions yet, but just to give an idea, if you know what a function is, you already know probably a good use case for a tuple. The thing is that sometimes we don't want something super structured, for example, a struct that we'll see in just a couple of minutes, but we want to be sure that the format is what we need. I want to start from this example, but I want to change this just a little bit. So I want to use I32, F64, and char, and here instead of 1, I want to put x, okay, like this, with a single quote, otherwise I will have an error. Okay, so we have this fixed length, okay, and this cannot change. We cannot change the structure of a tuple. Okay, so we can have this one, and now I'll show you a couple of things with a tuple, which one of them is the structuring. So we can destructure a tuple into individual variables. For example, here we can have let x, y, z equal tup, and then we can print. And then we can print ln, the value of y is y, okay? And here we should get a warning. Let's see. Yes, you can see we have the value of y is 6.4. We get a warning because we never used the variable x and the variable z. Okay, the variable x is this I32. Okay, it's not this one. Okay, nice. Okay. Okay, we can also access single tuple elements directly. Access by index. We can have something called 500 called and tup.0, 6.4. These are name of variables, by the way. And then we can have let x char, and then we can print all this value. Print ln. I want to change the value here. Maybe like this. Let's remove it. Let's just leave accessing by index. Control L to clean the screen. And then again, cargo run -q. Okay. We have a warning, but you can see we can have this character x at the end. If we want to print them all, there we go. Let's do it. The 500 and the 6 point. Okay. Like this, we have all three of them, and these were the tuples. Tuples are very important in Rust because they provide a really easy way to aggregate some fields. We want to return, I don't know, a character, a number, and a floating point number. In this case, we are sure that we have these multiple values. This is a compound type. We have multiple values in the same one. Okay? Nice. Could we interfere with the value of a tuple? It's mutable. We should make a test later. Let's focus on the array later, and then we can try. Okay. Now, the array type, this is very important because it's different from other programming languages. So arrays, in Rust, an array is a collection of elements of the same type, okay, but with a fixed length. This is very important because in other programming languages, you can have arrays with dynamic size. So here, for example, we can define an array 1, 2, 3, 4, 5. This is an array of 5 elements, of course, and the size cannot be altered after the declaration. And this makes them suitable only when we want to create something that doesn't change in size. If we want to make a dynamic array, we need to use something called vector, but these are like collections, and we'll see this in an upcoming lesson. As I said, as a kind of reminder that all the types in the array must be of the same type. And of course, we can access the elements in the array in the normal ways, I would say. Let's try. Control L, clear. Okay. We need to print them, of course. Let me remove it. Okay, let's print them. First and second, cargo run, and here we can see the number 1 and number 2 on position 0 and 1. We can iterate over elements in an array in different ways, but one way is this one, for element in R iter, and we can print the element. So here we can do like this. So for element in R.iter, and we have an iterator for this array. I think I said everything. As I said, for dynamic collections, when the size can change, Rust can offer different types of vectors, and we need to use another type in this case. Use case for tuples, as I said, it's a good, for example, if we want to return something from a function and we want to return exactly a group of types. Think about a function and I want to return, I don't know, a floating point, an integer, and a string or a character, okay? Okay, nice. Okay, custom types, and then we are done. So here, okay, now custom types, and then we are done for today. Custom data types. So we'll see two different types of custom types. We'll see two different types of custom types. The first one is structs. Structs is very important. I already used this in another video. And we can, basically structs are for when we want to define a structure, hence the name. And the interesting fact is that usually when we define a struct, we can do this inside a function. I think it's allowed, but usually we want to do this at the top level, out of the scope. So for example, if we want to have this struct in different functions, we can still have it. So usually we define the struct here. I want to have as a struct a person with just a name and an age. Okay, in this case I'm using this type string. We'll see this in an upcoming lesson because strings are not so easy to understand in Rust. So this will need a different lesson. Okay, they are similar to tuples, but they have named fields. Tuples, they don't have named fields. And as I said, so structs are useful when we want to give a group of values something, but it's very important to give names also to the key that access to the values. For example, here we can do let person equal to person. We can have a name and an age, and then we can print the person name and person age like this. If we want to, okay, moment, okay, if we have this struct and we want to print, we do cargo run, and we have person name is John and age is 25. So we are using this. I've used this in a previous video when I needed, for example, a model for an object to insert into a database. I've used a username with a name and a password. If you're interested, you can just check Rust full stack video on this channel, or also CRUD API. I use a struct because it's very useful in this case. Okay, let's see. Will there be a separate video for methods in array like R-iter? Yes, of course. We can think about an assignment. I really like the idea, but I need to prepare it. I like this point of view. Nice. Okay, last type, and then we are done for today, is anam. With anam in Rust, I'm a huge fan of enums. You can enumerate different types when we know that something will be on a specific type, and they're very powerful and they're very custom. We'll see this example now, and we can have a pattern matching to understand which kind of type we have in this case. For example, let's make a very simple one, traffic light. We have a traffic light. Let's say that it can be only red, yellow, and green. We have a working traffic light with these three lights. In this main function, we can have a single light. We can define a function. We can define a variable called light, and we can assign the traffic light red. So we are assigning this value to this variable. Now I want to show you something that I am a huge fan of, which is the match statement. Match statement is one of my favorite ones in Rust and in many programming languages. It's similar to a switch, but I love this very compact syntax. So basically we have this light. I also am a huge fan of this keyword. So match. So the light must match some of these use cases. The key part here for the match statement is that I need to implement all the possible paths for this variable. I'll show you what I mean here. Let's say that I have here, okay, of course, this is a very short piece of code, so it's understandable that it will be hard to make a mistake here, red, yellow, green, red, yellow, green. But let's say that we have 1000 lines of code. This might become super complicated here now. Let's try to run this piece of code and let's see how it goes here. I want to show you also something. So, okay, let's read. Here we have, at the end we have this stop. So this does mean that we have this traffic light red and we have stop is as an output. But what if I forget, I don't know, I forget that traffic light can also be yellow. So I use the match statement, but I just think about the cases red and green, because I don't know, a traffic light is red and green. I made a mistake. I clear here. I do cargo run and I have an error. And I would like to stop for 10 seconds to show you the powerful of this. Because it says, A, you ensure that all possible cases are being handled by adding a match armed with a wildcard pattern. So either I add a wildcard or I need to implement. This can save me, because let's say that I do something like this with a couple of if statements and I forget the yellow path here, I could have some big issues. The match statement forces me to implement things in the correct way. I love this. I love this match statement. Also, I think it's easy for me to understand. Like this has to match one of these paths. What do you think about this match statement? I'll make a separate video about this. And of course, this ends the lesson about these very basic data types. It has been 40 minutes, 50 minutes.